everyone. Let's talk about asynchronous control flow, or just async as it's commonly called in JavaScript. Once again, I have to forgive me. This is my fourth lecture of the day, and I seem to have lost my voice. We'll talk about asynchronous control flow. Asynchronous or asynchronicity, I've heard it called, is a fundamental part of JavaScript. You cannot program JavaScript without dealing with asynchronous code. So we'll talk about asynchronous, but we'll first talk about, well, if we're talking about asynchronous, that implies that there is something called synchronous. A meaning the opposite of synchronous, so it's asynchronous or not synchronous code. So we'll talk about synchronous code and then asynchronous code. We'll talk about the set timeout and set interval functions. We've played with these a bit already. They're kind of like the two common ones we use to demonstrate these concepts in JavaScript. I'll also talk about some file system functions. And if we have time, we may or may not touch on a really interesting concept called closures. I'll put an asterisk beside that because we're not sure if we have time for that. It's not really async, but it's just so cool. It's just fun to talk about if we have time. Okay, so why do we need asynchronous code? Because really, all the code we've written up to now, all of low tide, has all been synchronous. All synchronous code. And what does synchronous code look like? Let's make ourselves a little file here. I'm going to make a file. I'll call it 0, 1. I number them so they show up in order. I'll call it blocking, because that's what synchronous code is. Sometimes you'll hear it called blocking code. All right, and let's write ourselves some code. Let's write console log hello and make a variable. Let's make a variable const name equals Alice. Alice being common first name of the computer Scooby gang. Was it? I think it's Alice, Bob, Carol, Dean. There's a Dean in there as well. There's also a Mallory, which stands for malware. I really feel sorry for anyone called Mallory. They seem to get a bad rap in our world. We'll go hello world Alice. Now you notice I'm getting this weird name is deprecated thing. That's why I try not to name variables name, although it still work fine. For some reason, JavaScript used to have a thing called name. It's no longer used, but VS Code notices that and says, hey, you shouldn't use that. We'll use it. It's not going to cause any problems, but if you use it in your code, you might get that funny warning. It's not even an error. No red or yellow lines, just one of those funny things. Let's try and run our code. There we go. There's my code. Oh, hold on. Let's make sure in the right place. And CD async. There it is. Okay. Go node my 0, 1. Now, of course, we know we can go node and then type. And then if we press tab on our keyboard, it will autocomplete. It'll take whatever starts at 0, 1, in this case, blocking. We're lazy people as developers. I mean, if we liked work, we'd have real jobs, right? So no, we like, sitting in our pajamas and coding and drinking junk food all day or junk pop all day. I used to work for the number of years ago. I worked for a small company called IBM. They're a pretty large company. And I worked for what was called their IBM Software Research Lab. And IBM has a couple of these labs, and they are exactly what you think they are. A bunch of people chugging Coke all day long, living off junk food, and just on a sugar high all day long. And they feed you unlimited, you name it. Because our room is just stacked to the ceiling of every possible junk food you can imagine. It's all free, of course. They want to keep you going. So I was there about 4 years. Nice place. IBM's a great company. So, all right. So I'm going to call my node 01. Oh, hello, Alice. So this is an example of synchronous code. What does that mean? It means code that runs one line after the other. Code we've already written in low tide. it's going to run line 2, and then it will run line 3. It won't run line 3 first. It'll run line 2, and then it'll run line 3. Really obvious stuff, of course. This is synchronous code. Okay, so the way it works is code always runs in a specific order, and we can depend on this in JavaScript. We'll talk more about this a little later, but we really depend on the fact that code runs top to bottom, line 2, then line 3, and there's nothing in between lines 2 and 4 now, so nothing's going to happen here. Nothing happens here. That may seem obvious, and of course not. There's no code there, but that's not really the case in some other languages, and we'll talk about that later. But in JavaScript, you can be guaranteed that nothing will happen in between lines 2 and 4. You'll get name equals Alice, and when you get to line 4, name will be Alice, and you're going to console log it. Okay. So let's write something else. Let's write maybe a long-running piece of code. Let's make ourselves a for loop. For. And VS Code has all these really cool templates. Pick one of these here. Look at that. It gives you a template. And it's actually got some placeholders. If I press an I, it puts I in the same place. Press tab. Oh, that's kind of scary. There. It jumps to the next barrier. There it is. So I, then A. It assumes you want to do an array dot length. I'm just going to go 10,000. There. I'll do a loop of 10,000. There, right. And then I press the typical C style. And what I'm going to do is I'm going to just generate a random date. I'll go const date equals new date. This is one of the things we use a lot in JavaScript. It's a date object. And I'll console log that date. Let's make it 5,000 there for now. Okay. So let's run this code and see what happens. As you can probably imagine, we're going to get 5,000 dates. Let's take a look at how this worked. So look at the time. So there we go. This is our date, minute, second, and 1, 2, 3 milliseconds. So let's count them. So in 1 millisecond, it ran 1, 2, 3, 4, 5, 6, 7, 8, 9. How many is that? It's quite a few. In 1 millisecond, that's a lot. Wow, how did it ring? Then it changed. Okay, so up to there is 1 millisecond. That's quite a few. So JavaScript is very fast. It's very, very fast. Obviously faster than a human can be. So, but however, compared to some other languages, turns out JavaScript is very, very slow. Compared to something like C, which is blazingly fast, or Java, which is very fast, or other languages, JavaScript's actually kind of slow. But it still did an awful lot in 1/1000th of a second. That's a lot of code. So for purposes, it's pretty fast. Okay. So let's go ahead and log something at the end of our code. Let's put our console log. We'll just say end of our code right there. Okay. Now we expect we're going to get end of our code after all this is finished. So we're not going to get this end of code until all those print. Makes sense. So we could say this is blocking code. This is code that blocks. The browser is, or JavaScript is busy. It is doing something, so it can't get to here until this is finished. Once again, it's pretty obvious, but this is an important concept. It's blocking, okay? So in other words, JavaScript is busy. It can't get to here. So, but what if I want to see this end of our code and at the same time run this loop? Well, I can't do that. If I'm doing some work, I can't do any user UI, which means my user might see nothing. This can be a problem. And why is it a problem? Because of browsers. In browsers, people expect things to happen all the time. Like when I do this, it's actually doing some fetches, but that takes time. If it was blocking, when I type a D, the whole browser would freeze while it goes and fetches that stuff. And then it'd free up again. It would make for a very, very poor user experience. And that is because JavaScript. JavaScript is, as we know, single-threaded, and also call it non-preemptive. I'm sure that's not correct. Doesn't look right. Preemptive. Preempt. I'll do this instead. That's not correct. Anyway, non-preemptive and single-threaded. That means JavaScript can only do one thing at a time. It can't do two things single-threaded. Non-preemptive means it can't be interrupted, which means our code, nothing can happen in between here. Nothing can happen while this loop is running. It has to complete, and then it runs our user output end of our code. Okay. So let's do 10 loops, a little easier here. We'll do 10 of these. Okay. There's my 10. And what I'll do is I'm going to do it again. There. Okay. Now that was pretty fast. But still, if it blocks my code, it can still cause freezes in browsers. So things still have to happen in order. Okay. So let's talk about asynchronous. This is obviously synchronous code. Let's talk about asynchronous code. And asynchronous code is a foundational part of JavaScript because it's single-threaded. Let's do an example of asynchronous code. Let's make a little file here. I'm going to call it O2. I'll call it my timeout. Timeout.js. Okay. And we know we've done this before. I think we've had a bit of work in our Compass work where we start playing with the set timeout function. And it's a great introduction to asynchronous. This is why we use it all the time. It's easy to understand, and it's really built into Node. Okay. So we have a set timeout. Looks like this. Set timeout. In fact, it's so popular, VS Code has it built right into it. There. Set timeout takes two arguments or two parameters. One is a function, and one is the timeout in milliseconds. So something you want to have happen, which is that, and then it'll happen after a timeout. For instance, I could write a set timeout with 1 second. So 1, 2, 3, 1,000 milliseconds, and I'll just console log this. I'll say we are inside the callback. Okay, there's my set timeout. So I should get runs. Let's call my 02, 1 second. Oh, we're inside the callback. Now that makes sense, but what happened? So what's happening is, of course, I've got this callback right here. In fact, to make it more clear, I can even do this. Let's make a function. And we'll call it callback. There. I will make it console log this, and then makes it more clear of how set timeout works. There. So set timeout takes two parameters, a function and then a timeout, and we'll call this function when it finishes timeout. And 1 second. It's a long 1 second. Oh, maybe it's me. Okay. So now it turns out set timeout is not part of JavaScript, strangely enough. I always thought it was, but when I dug into it a little farther, no, it's not part of the language. It is provided by the runtime. What's the runtime? Well, in a browser, the runtime is, well, the browser's JavaScript runtime. But when we're here, the runtime here is Node. So you may have done some reading in some of the things that Node provides. I think you had a lecture about that earlier. And one of those things is the runtime, and it is set timeout is included in that. So that is Node. So what's happening here? I'm calling set timeout. What I'm doing here is I am asking Node to start a timeout. And I'm giving it this callback and that parameter. So this is actually an instruction to the runtime, not to the language. This is me asking Node to start a timeout. Okay. And then this timeout is requesting. It's actually returning immediately. And that's a really cool point. Okay. Let's demonstrate this. Let's put this back as an anonymous function again. This is how we usually see it. Let's do this. Let's go console log, and we're going to start of the code and to the end of the code. You know that was coming. End of the code. Okay. In fact, let's put numbers so we can see the code. 0, 1. There we have 0, 2. And we have 0, 3. Now we're used to things running in order, where code runs one line after the other. Let's watch what happens here instead. Okay, let's clear that. I should put a clear then a semicolon. That actually chains two commands. It'll do a clear and then it'll run our code. And well, that was odd. Look at that. Start of code, end of code, and then I get my two. We are inside the callback. Okay, so we can try another one. So another to callback and see what happens. We'll do 2 of these. There. Do another one. Maybe I'll make this 2 seconds instead. There. So 1 is 1, 1 is 2, and I'll just call this one, I'll call this 03. Sure. And I'll call this one 04. Let's run it again. Oh, okay. Well, the same thing happened. So what's going on here? Well, this is how async works, and this is so critical to understand about how JavaScript works. And let's look at rule number 1. We have some rules of async. So rule number 1. There. Okay. Async functions never run until Java is finished. So async callbacks always wait until JavaScript is not busy. In other words, not running code. And we can tell because these didn't happen until my code was finished. So my code got to the end and it finished. Line 13, nothing there. And then these got called. Well, what if I put in some arbitrary delay in here? So for instance, why don't I put in a big for loop again? Or, okay, let's try this. Let's go for, oh, there it is, 4. Where's my 4? There, right there. I'll go I, and I'll say is less than, what should I say? 10,000. There. I'll go 5,000. 5,000. Okay. Oop. There. Delete that. My template's getting wonky on me. There. 5,000. And just I++. And I'm just going to console log my I, just to do something. Okay. In fact, let's make a date. doing a date's kind of an expensive operation, so we'll do that here. Same code we had before. Let's take our date like this, there. And we'll just console log our date and maybe the I just for fun. Okay. So, and let's wait maybe a shorter period of time. Let's make just maybe 30 milliseconds. Okay. And we'll have this one wait maybe 20 milliseconds. Okay. Let's watch what happens. So this is going to run, it's going to set a timeout. We're going to run this loop, and then we're going to set another timeout. Now, there's a really good chance that this is going to take longer than 30 milliseconds, which means this timeout should fire before this loop is finished. Okay. Let's watch what happens. Callback. So it didn't get called anywhere in here. It still got called at the end. Well, maybe I didn't wait long enough. Let's make this 10,000 there. Make sure it really waits a long time, just to be sure. Because we know that this is probably going to take longer than 30 milliseconds. So you would expect that we are inside the callback to should appear someplace inside here, right? Let's take a look. That was almost a second. But strangely enough, it still happened at the end. And honestly, it doesn't matter how long I take, 100,000, that's how long that takes. It's taking a while. Yeah, it's taking a long time. That was clearly more than a second. Still, my callbacks did not fire until JavaScript was finished. And we can take that to the bank, if you will. It's guaranteed. They never run until JavaScript is finished, or sometimes it's called the main thread. So even though I'm sure this timeout timed out and Node was ready for us, but we had no way of knowing that. Think of it like if doing some work and you got your cell phone with you, and I'm doing something. Maybe I'm cleaning out my garage or doing something else. I'm busy. And my mom texts me. She still uses text, by the way. Yeah, like actual SMS text. And I like a letter. Hello, Gary. How are you? Like, not like, what's up? It's like, hello, Gary. How are you? We are all good here. Like, her texts are like this, okay? Well, I'm busy. I got to text my mom, but I'm doing stuff. So I can't check my messages yet. Okay, I stop. Maybe I was driving. Can't check messages then. I stop out of my car. Oh, look, a message from mom. Oh, it happened a while ago, but I couldn't check for it, so I couldn't react to that message. Same thing happened here. I'm sure that Node tried to notify me 30 milliseconds later, but I couldn't do anything because I was busy. And even if I put this here, let's try this. There. In fact, let's even make it shorter, even 100. It doesn't matter. It's always going to occur last. Okay. Now, interestingly, if you notice, which one finished first? It wasn't the first one I called, was it? It was the first one that finished, or more precisely, the first one that notified me or notified JavaScript that it was done. And I said, this one in 30 milliseconds, notify me. And I run this. And this was 20 milliseconds. So even though this one came first, it looks like this one finished first. So this was the first one to finish. And that's what gets the message first. Okay. So that's how it works. It's non-preemptive and single-threaded. And that's a hard rule. Nothing can ever happen until end of your code. Nothing can happen. And we count on that. We use that feature of JavaScript, knowing that nothing's going to happen, any of our callbacks will ever happen until our code's finished. That's very important because we use that a lot. Okay. Well, how can I return stuff from my JavaScript? Okay. Let's try a little example here. Let's make a another file. Call it O3. There we go. O3. Return stuff. Return. There. Returning. How do we return things from a function? So I'm going to make a simple code. Let's go ahead and console log. Okay. Start of my code. Start of code. With the usual. I like putting this in here. And end of code. Oops. End of code. I'll call this O1. I'm not quite sure what the last one's going to be, so we'll kind of add it as we go. Okay. And what I'm going to do is I'm going to write myself a little function. I'm going to call it my function because I can't think of anything else. So my function, and this function takes a callback. Now we've done callbacks already. Callback. There. Okay. And let's add some stuff in here. What we'll do is why don't we go ahead and have our callback function const log first. Make an object const. We can call it user equals there. And we'll say user name. I don't like user name because we get the funny JavaScript thing. Alice. There. And we're going to console log this. We'll call it, we'll say O2. And we'll say before the set timeout, because we're going to do a set timeout here. Timeout. There. And then we're going to write a set timeout. Set timeout, and I template. Love that feature of VS Code. Set timeout, and I'm going to console log inside this one. There. O3. We'll say we're inside the set timeout. Okay. And what I'm going to do inside the set timeout is after my timeout, I'll make it 500 milliseconds, just a half a second. Doesn't matter. I'm going to be changing the content of this object. I'm going to say user.username equals Bob. Alice and Bob. Okay. Great. And then I'll call my callback. There. Okay. So let's go ahead and now we have a console log. One more console log here. We'll put this after set timeout. Call this for after the set timeout. There. We're going to trace this code. Okay, so now, of course, I have to call my function. So I'll say my function. There. And my function takes as a parameter another function. So I can write one or just do it in line, doesn't matter. And I'll just do this. I'll say, give it anonymous arrow function. There. And I'm going to console log. And this is going to be 05 inside the callback. It's getting complicated, isn't it? Okay. All right. And then let's just go ahead and do 06 right here. 06. How we doing? So we got 1, 2, 3, 4, 5, and 6. Okay. What do we think is going to happen? What order do you think things are going to run in? Let's take some guesses. Okay, we got 1, 2, 3, 4, 5, 6. So that's one option. Is it going to be this? 1, 2, 3, 4, 5, and 6. What do we think?
Well, I
Or
think first, yeah, I think
sure.
first goes 1 because it's at the top. Then because you called my function, probably there has to go 5. After that
Okay, 5,
goes, yeah. After that goes 2, 3, 4, and 6.
6. Okay. All right. Who else wants to in the chat if you want to put your place your bets? I went to a casino for the first time in my life, only because I had to walk through it to get out of the hotel. So it's like, wow, look at all these people putting all this money down. So it's like casino. So we have one bet: 1, 5, 2, 3, 4, and 6. Okay, let's take a look. So we have our function, my function. Then it's going to call my function. Let's give it a try. Okay. And this was called our 0, 3. Okay. Kind of close, but not quite. So we got 1, 2, 4, 6, 3, 5. Huh? What on earth has happened here? That is totally not the order we have the code in. So now we notice things are occurring out of time. It's like Back to the Future, or what's another really cool time show? Like 12 Monkeys, right? Anyone seen that movie? The Bruce Willis one? The series is good too. Who doesn't love 12 Monkeys, right? That was a great show. I think one of Bruce Willis and Brad Pitt, he was awesome. Wasn't he great? Man, his monologue is fantastic. So yeah, love that movie. Things happen out of time. Like, wait a second, he goes here, he has the wound, and then he gets shot later. What happens? And he shows up 2 years before he meets her the second time. My head hurts. So same with this, right? What's going on? Things are occurring out of sequence or what seems to be out of time. This is kind of weird. So let's trace what's happening here. Okay. So, and this is important, important skill, being able to trace asynchronous code. So that's an easy one. One, we kind of all guessed one, right? Had to happen. Then we have this. Now this doesn't actually do anything. This just declares a function. It creates a variable called my function, and that's it. Nothing happens here. So this is just creating a variable called my function and putting the stuff in it. Nothing happens. Then it gets to this line here. It calls my function here. Okay. And then it goes here. It goes to line 3, then line 4. Then it calls line 6. There. O2. It gets here. Then it calls a set timeout. But a set timeout, it is just a request to Node to set a timeout. Another interesting thing or another rule of asynchronous is that asynchronous functions return immediately, no delay. So this set timeout, it returns in a nanosecond, probably maybe 2 nanoseconds right away. Nothing happens yet. It just puts in the request and drops right through. Then we get the 4. And sure enough, we got the 4 after the set timeout. Now our function is done. Okay. And then we get 6, end of our code. And now JavaScript's finished, which means this set timeout is now free to be to notify us that it's good to go, and it fires. console log O3 inside the timeout. There we go. And then it does this, console log, and then it calls our callback, which is right here, O5, inside the callback. It's a little different, isn't it? Things don't quite happen the way you expect. So callbacks take a little bit of thought when you're building them. Okay, so well, what can I do here? Like, how do I get my object out of here? Like, I want to have my Bob. So if I return my user, of course, I've changed my user to Bob, haven't I? So let's go here and say const new user equals my function. Okay. And we're going to console log our new user. I'll just say new user object. Okay, so our my function returns the user. We're grabbing that here, and we're going to use it here. Okay, take a look. Well, it's Alice, but we expected Bob. What's going on? I'm returning a user, but clearly I'm getting Alice. Well, it makes sense because now that we know how set timeout or really any asynchronous function behaves, this returns immediately. It jumps right to line 14 and then there, return. So this set timeout never had time to finish. User is still Alice and it returns. So clearly using the return value from an asynchronous function is not that useful. So that's kind of the rule 2 of asynchronous functions. So rule 2, there. We don't return anything from async functions. I mean, we can, but it's not useful. I mean, I'm certainly returning something, but what was returned is useless. It doesn't do me any good. So, well, what I want to do now is I want my new user to be equal to Bob. So how can I do this? Well, I could maybe try and return the user here. Sure, let's do that. Let's return the user right there. See what we get. Well, we get the same thing. We get Alice. Because think about this. Who is this returning to? Well, this return is actually returned to set timeout. And set timeout doesn't care what you give it in return. It doesn't use it. So the set timeout function couldn't care less what we return. Okay, so that's not going to work. Well, why don't I instead do something really cool? And by the way, this is a really bad practice. Why don't I put this right here? I'm going to do a set timeout again. Here, let's pull the template one, that one. When you see the square boxes, that usually means some template code in VS Code. So I'll click that one, and I get that. And let's wait a few seconds. I'll wait maybe 800 milliseconds. And that will be enough time for Bob to be set. Okay, so there. Let's do a random wait. Okay. And then I will console log the new object. Put this here. There. So I'll wait some time and then I'm going to print the user. Take a look. Not long enough. Okay, that worked. Look at that. So I inserted a arbitrary delay in my code, and I was able to get my Bob, because now it was enough time for this function to finish, and then I can use that. But this is a really, really bad idea. We don't use arbitrary timeouts. In fact, I'm going to add that as a rule, because really, we'll just say it's a rule. Don't use arbitrary timeouts. And the reason is pretty straightforward, because you can't guarantee when this is going to finish. For instance, if I tried to add a wait, maybe I'm fetching some data from a website, and I know that takes roughly 200 milliseconds on average. So I insert a wait in my code of 300 to be safe. Well, what's going to happen? Well, first off, my browser is going to just sit there and do nothing. It's an unnecessary long amount of time. Or what if the server took too long and I get no data at all? I end up getting Alice. So if I don't wait long enough, so for instance, if I only wait 400 milliseconds, what's going to happen? Was not long enough. Wasn't enough time to finish. So very, very, very bad idea. Okay. So what we want is to make sure that we always get the value at the correct time. And that's really the critical part of how we use asynchronous code. And this is unbelievably common in JavaScript. In fact, this will make up easily half of the code you write will look like this. Let's see what happens here. So what's happening is I've got this function called my function. In fact, let's make a callback here. I'll make a function. I'll call it, doesn't matter. We'll call it done. There's our function. I'll make it do this. There. Whoops, just want that one line. There. And now I'm going to pass my done function to my function. So I'm passing the my function, this function done. And works the same. I get my code. All right. So how does that help me? Well, what I want to do now is I want to have the function return its value in the callback that I gave it right here. Instead of returning user here, I'm going to return, and it actually is a return the user here, right there. I'm going to call the callback I was given, and it's going to send that user back out through that callback. So now my callback has a user or data. It doesn't matter what it's called. Call it data. It's for fun. Because I know that when I call my function, it will give my function a parameter data. It's a return value, but returned as a parameter in a callback. And this is really, really common. Make sure I understand what's going on. I'm giving this my function a callback. It's going to call that callback with a parameter, the finished user, with Bob, right? When I call that function, I know that it's going to call a function with a parameter. So I give it a function with a parameter. I give it what it expects. It expects a function with a single parameter. And let's console log data. Okay, let's watch what happens. And we get Bob. This is the key to asynchronous code in JavaScript, where we return values with or by calling a callback. In other words, this function will return me its value here in that callback. So this is not useful at all. Can't use that. you will very seldom, at least in this form, see a return value. It's just called this way. And now this is the return there. Now you'll commonly see it done like this instead. You'll see it done as an inline or like this and done like this, right? Done and console log data like that. Okay. You might see it done function if you want. They're the same thing, but we generally use arrow functions as what are called anonymous callback functions or inline functions. It's very, very common. We don't normally use the function keyword here. Okay, we normally take this and instead make it an arrow function. But a good point though. When do we use arrow functions? When do we not use them? And that is open for debate. A lot of senior devs generally stick to the pattern of when I'm making a named function, I say function there. That's how I make a named function. But if it's an anonymous, an inline function, I make an arrow like that there. That's generally what most people do. But honestly, whatever company you work for, they'll have their own standards. So it really doesn't matter. But rarely will we see a callback called in line like this, like this. That'd be quite uncommon to see it done this way. And of course, I'm going to go ahead and contradict this in a couple minutes anyways, but you'd commonly see it done with an arrow function. And we know that if it's a single parameter, you don't need parentheses around the parameter. But if you have two, you have to have that. We'll do that in a few minutes as well. Okay, so now, oh, and I get my console log, oh, data. Here we go. Oh, hold on, console log, done, data, there it is. Okay, and I got my data. There, got my Bob. All right, so this is how we call things. Very, very common. Now, interesting point. Let's try another set timeout. Can we call set timeout in a loop? Let's try this. Let's make ourselves a file really quickly here. We'll call it 04. I will call it loop timeout.js. Okay. And let's make ourselves an array. Const delays. I'll just do some random numbers. 73, 12, 4, 12, 124, 86, 9. I'm just making up numbers as they go along, right? There. Oh, that's a little long. Make this. That's fine. It's not bad. I'll call that 3. And 90. That's not bad. That's a pretty good spread, I think. Okay, there's my delays. I'm going to loop this array. And of course, we use a for of. Interestingly enough, look at that. There's a pattern built into JavaScript, into VS Code. Look at that. For delay tab of delays. Now, good point. When to use const and when to use let. The age-old question. What should I use? The answer is always const. Always make const. Until it barks at you. If it complains, then make it a let. But until then, just make everything const. You'll be fine. Okay. It'll tell you if it wants a let. So don't agonize over let or const. Just make them all consts. And it will tell you if it wants a let. In this case, this is fine with a const. Okay. Extra comma. Good point. This is actually perfectly fine. You can do this in JavaScript, but not in JSON, as it turns out. And by the way, we all know how to pronounce JSON, right? It is not JSON. It is JSON. I know because there's a video of the guy who invented it, and they asked him, how do you pronounce it? He goes, it's JSON. He goes, it's JSON. It's like the name. It's not JSON. It's not French. Okay, although it sounds cooler. JSON. I like that. JSON. It is JSON. Okay. So comma, no comma, it doesn't make much difference in JavaScript. Okay. And now we're going to set a timeout here like this. And let's go ahead and console log our delay there. And there, like this. And we'll wait so many seconds. And let's watch what happens. All right. This is R04. Oh, and delays initialization. Oh, of course. Delay of delay. Yeah, 1S. There we go. Look at that. Oh, interesting. They're all running in order, aren't they? Even though these are kind of out of order, it rearranged them all in the proper order. Now, why would that have happened? That's magic. I didn't even have to do a sort. In fact, it did a sort for me. It put them all in order, lowest to highest. Well, let's think about this. Remember, this set timeout function. Let's do a quick console log here. What's happening? Setting time out, and this will help us understand why this works. Look at that. Once again, asynchronous functions like set timeout return immediately. So it blasts through all of these really quickly. And then when it's finished, in fact, let's do our usual console log, end of code, and watch what happens. Look at that. So once again, nothing happens until the end of code. So it blasts through these really, really quick. Okay. All right. So that's kind of a recap of or a intro to set timeout. Let's take a quick 10-minute break. Okay. See everyone in 10. All right, so we had our set timeout and kind of beat that one to death. There's one more thing I want to talk about with set timeout. Let's take a look and see what happens if one of these is 0. What if we give a set timeout a 0? Let's take some of this code. What we'll do is comment this. There we go. Comment this. And there. And let's do this. Let's go set timeout. There. And we're going to give it a 0. Why not? And let's go const result equals. We don't normally do this, do we? Take the return value from a set timeout and we'll see what happens. We don't really care what happens here. We can just console log anything important. Done is good enough. What I want to see what is inside that result that I got back from set timeout. We'll give it something meaningful. We'll give it a 100 for now. Okay. Set timeout 100, console log the result. Looks like it's an object with a lot of interesting stuff. We have these underscore values. Now, this is a convention in JavaScript, in objects. If something has a leading underscore, it usually means you should not touch it. You can look at it, but don't touch it and never change it. Because in JavaScript, there's no concept of a private member of an object. It's not possible, at least not easily in JavaScript. So people tend to agree that, yeah, if I want something to read only, I'll simply put an underscore and expect no one to touch it. But they are useful. And there it is. That's my timeout 100. And that's what I asked for. So if I give it a 50, I'm going to get 50. What happens if I give it 0? What am I going to get? 0, you'd think. You get 1. So 1 millisecond is the default. In fact, if I give it no parameter, what's going to happen there? It's a 1. So the default timeout for a set timeout is 1 millisecond. In fact, if I give it a string, what's with this? A, B, C. Oh, well, it ignored it and it gave me a 1. So if you give it something that's not a number or a positive integer, it'll just make it 1. Okay. All right. Let's talk about something else. Let's talk about another function. We talked about set timeout. Out. There we go. In fact, I'll put that in there. Another one is set interval, which is a much more interesting function than set timeout and has a lot more power. Let's go ahead and make us a little file here. Make a file, I'll call it 505, call it interval.js. Okay. And what I want to do is call set interval. It turns out set interval looks the same as set timeout. It has the exact same format. A callback and then an interval in millisecond. So I'll say every 500 milliseconds, sure, or 1,000. Every 1,000 milliseconds, I will do something. Console log, I'll just say hello interval. There. And let's call this one. 5 now, so 5. And there we go. Every second. And it goes forever. It never stops until you kill it. And how do we kill something on the command line? Not as obvious as you might think sometimes. So let's take some votes. How would you kill this terminal program yourself? Anyone? How would I kill this thing? Control C, great option. Anything else besides Control C that people use? I always ask this because it's kind of important. Okay, it is Control C though. Control C, there. And even on a Mac, it's still Control C. That's like a universal stop command. Okay, or break sometimes. It is
Can I ask a
Control
question?
C. Yes.
Like why does it print logs it out all the time? You didn't set the loop.
That's right. This is now set interval, not set timeout. And that's what it does. This means do this every 1,000 milliseconds forever and keep doing it and never stop until you're killed. So when I started, that's what it does. It keeps on running the same thing every second. So now it's an interval. It's much more useful. We can do all kinds of really cool things, interactive experiences using set interval. Now, we use Control C to stop. One thing, please do not do. Do not go Control Z or Control Z. Please don't do that. If you do, you get this funny thing. Node 05.js. It's stopped, but it's not killed. In fact, it's in the background. I can go BG, and now I can type, and it's still going. Oh no, what do I do? It hasn't stopped. Even though I've stopped, I've got back to my shell. It's still running. Well, now I've got a real problem because Control C doesn't do anything because it's returned back to my shell. So please make sure you don't use Control Z when you kill any process. All that does, it puts it in the background. It'll be more important when we use Express and we have a service running that we have to stop. So what I want to do, I want to be able to stop this programmatically. So why don't I take my code and let's make a variable. I'll use a let because I want to change I equals 10. And I'm going to count down 10, 9, 8. So let's just count down I like this. And I will say I minus minus. Okay, so now we should count down for us. Let's make that slightly faster. Make it 700. Or 10, 9. Oh, perfect. Look at that. 5, 4, 3, 2. Blast off. Oh, just keeps on going, right? So what I want to do, I want this to end when it gets to 0. Well, what can I do here? Well, it turns out there is a function called clear interval. And looks like this, clear interval. And it takes as a parameter the address of the interval you created. So if I do this, const, I'll just call this my obj. It's an object. Equals, there. Set the interval, and then I'll clear the interval like this. Okay. Let's give that a try. Huh. Well, I got nothing at all. Well, what happened? What mistake have I made? What's of course happening is this is asynchronous. So it calls this, then immediately calls the clear. And this never has a chance to start, does it? Okay. So with my clear interval, I can't stop it here. I have to stop it inside one of these loops, don't I? So what I want to do is, and I could, I suppose, wait, maybe like this, then go away, set timeout again. There. And maybe set timeout to 7,000. That's, yeah, 10 times. That's right. Yeah, so 10 times, actually, I guess it's 11. So 7,700. There. And that to give me from 10 to 0. I'm guessing. Take a look. And then I'll call the clear interval. Let's give that a try. 9, 8, 7, 6, 5, 3, 2, 1, 0. I was pretty close. Not bad. I didn't get to 0 though. Huh. Let's go a little bit longer. Maybe go 7710, a little more than 7,700. What do I get there? 10, 9, 8, 7, 6. There we go. 2. That's not bad. Okay. So what's happening is I have what's called a race condition where I have these two competing things happening and you're not guaranteed which one's going to happen. When it's exactly the same, you can't be sure which will happen first. Maybe 7704 will guarantee it'll happen first. Who knows? I'll get my 0 first and then this one. Okay, it still didn't happen. So this is clearly not the way to do it, is it? What I want to do instead, I want to clear my interval inside here, don't I? I want to say if my I is, let's say, less than or equal to 0, or maybe less than 0. I want to go to 0. So less than 0, then I will clear my interval. That's what I want to have happen. Okay, here's my code now. So it goes through the I right there. It decrements the I every time. And when it hits 0, or less than 0, it'll clear it. I got to be careful because it's going to drop through. So I probably should put a return there. This is a filter, right? We probably talked about filter pattern. This is a filter. It'll exit before it gets to here. Okay, I could do an else as well. And put this in here. But then that's really, really ugly. And you will probably, you can Google online, don't use else. Like ever. Like almost never use else. As a senior dev, when I see an else in code, I immediately see what's going on there. That looks like a bug. Elses are that rare in code. You should almost never use them. For example, low tide, not one else in the entire project. All the code from this week, no elses. I think we need an else. I think next week we have a place we could use an else. There is one small place we could use an else in one application this week. The rest of it, no else. Don't use else. In fact, let's Google that. It's actually a thing. Don't use else. Let's take a look. And sure enough, look at this. Never using else. Don't use else. Stop using else. Don't use else. Yeah, don't use else. It's considered we call this a code smell. Something is fishy in the code. So when I see an else, or other senior devs, they see an else, they're like, their eyes are drawn to it. What is that? So instead, we use what's called a filter pattern. We filter stuff out and then we return. It also reads better too. There. So now I'm going to call my clear interval if my timer or my count is less than 0. Let's give it a try. 8, 7, 6, 5, 3, 2, 1. Hey, it worked. Look at that. And it ended exactly at the right time. Whereas a set timeout might not be totally correct. I might wait too long, or I might not wait long enough. But with this, it happened at exactly the right time. Call my clear interval. Okay. Now you may have noticed in Compass, there's another way to clear an interval. Anybody remember that one? What does Compass say? There is another way to clear an interval. Who knows what that is? There's one other way. It looks like this. No pun intended. Clear interval. This. This is also an acceptable way to clear an interval with clear interval. This. Let's try this. You know, with this, the jokes write themselves, really. Okay, let's try this. Okay, there we go. Let's make it faster. That's way too slow. I'm getting impatient. 400. Here we go. There. Okay. 9 8s. Here we go. Okay. And what happened? It just sat there. Didn't do anything. It didn't exit, but what's going on? It hasn't stopped. What's going on here? That's weird. Let's add what's going on. There. I'll say, put it inside here. Clear interval. There. Console log is your best friend. When in doubt, just put console logs. See what's going on. Clearing interval. What do we got here? Okay. 5, 4, 3, 2, 1, 0. Clear interval. Oh, that didn't work. Clearly a bug. So what's my problem here? why can't I use this? And this is the problem. Huh? Another joke for this. There's lots of this jokes. This is the problem. Why can't I use this here? Now, we've done a bit of reading on functions, haven't we? What do we know about arrow functions? That's a little flaky or a little odd when it comes to this. Well, it doesn't have one. There is no this. There's no this. So this is undefined. In fact, let's try this. Console log this. What is our this? 10, 9, 8, 7, 6, 5, 2, 1. Empty object. So it's not undefined, but it is sure not the handle to my set interval, is it? So I can't use this. So because I'm using an arrow function, there's no this. But if I did this, did it this way instead, here we go with no arrow, and call it the more classic function. Let's take a look. 5, 4, 3, 2, 1. And there's my object. That was my interval, and it cleared. So there is an interesting situation. Because I want to use this, I have to use this kind of function with function. Not too common, but we end up doing this a lot when we start using jQuery in a few weeks, or about a month or two, because we tend to use this a lot sometimes. Okay, very cool. So now it's clearing just in time. So let's try something else. Let's switch gears, and we're going to now do file IO. Let's talk about doing file functions, because I mean, these are fun. But let's do some real world coding. We're going to read a file. So I'm going to make two files. I'm going to make myself a program. I'll call this 06, and I'll call it files, I guess, .js. Now, when you're coding for Node modules, because this is now part of Node, we know that JavaScript doesn't have things like file access or other things, because JavaScript is generally a browser language. But we have Node, which wraps JavaScript. And let's take a look at the Node docs. Take a look right there. And we have Node. We get a bunch of things, all this extras we get that are outside of JavaScript, but Node gives us. And one of these things is, of course, the file system. A bunch of other stuff. Net. We'll be using this a lot this week. We're going to write ourselves a video game in a couple of days here. OS path, lots of interesting things, but we get file functions. Okay, and we use them. So append file, change file mode, close file, read file. Okay, there's a read file function. How do I use that? Okay, so the read file function, take a look, some examples there. Okay, so there's one example. Another is an easier one. Read file. Oh, go back. Read file. There. Read V. Didn't quite jump to what I wanted. Read file. There we go. Okay. Oh, promise read file. Put another one here. fs.read file. There we go. So we can call two functions. There's two forms of read file. There is a read file function. Looks like that. There's also a read file sync function that looks like this. So two forms. As you'd probably expect, the sync format of read file is synchronous. It blocks. So you can call read your file and it will block your code. In other words, nothing will happen until the file is read. Probably not what you want if you want many things to happen at once. We do use it in small files and utilities, but generally we'd use read file instead. Okay. Let's do read file sync only because it's easy. So let's make a file here. We have to include our fs. So const, and we generally say fs equals require fs. Now we can call this any variable, but the convention is to give it the same name, fs. Now I need a file to read, so I'm going to make myself a really quick little data file. New file, I'll call it data dot, I'll make it HTML just for now, although it doesn't really matter. There. I'm going to put in some random text. Anybody heard of lorem ipsum? It's a fake Latin. There's a cool trick. Type in LOREM and look at this. You can generate lorem right in VS Code. Or lorem 5 gives me 5 words. Or lorem 25 gives me 2. So we're just lorem by itself. And I get a paragraph. I think it's 1 to 10. Lorem, I think it's maybe 9. Yeah, 9. I get 9 words. Okay. I'll just go lorem all by itself and I get a nice paragraph like that. Okay. Random text. Close that file. So I want to read this file. So I'll call fs dot read file sync. Okay. And I'll give it the name of my file. I called it data.html. Okay. Now in this format, I can use the return value. So const result equals read file sync my HTML, and let's console log our result. And now it should read my file. What do I get? Okay. Well, that's curious. Huh. It read the file, but what is this? What I got was the raw bytes in that file. Because files are stored just as bytes on a hard drive, right? And they're stored really as numbers, just individual numbers. But what those numbers represent depends on how it was saved. And that's what's called the encoding. And there are many types of encoding. Okay. Now, I think the file I created, my data HTML, if I look at my VS Code, it should tell me, there it is right there. It looks like it was UTF-8. And by the way, this is very, very common. UTF-8. So the read file function takes options. I can give it option for encoding of UTF-8, or also UTF-8 also works, by the way. They both work. I like to go to 8 because it is -8. Okay. Okay, let's put this here, by the way. It goes here in our read file right there. Okay, so there's our second parameter, encoding. So now we've said read the file, and when you read it, you should understand that those bytes are UTF-8. Let's see what it gives us now. And we get our data because we chose the correct encoding. There's lots of encodings. Let's go hex. I'll say was it encoded in hexadecimal? Take a look. Well, there we go. Now it's just hex. So as a rule, UTF-8 is a pretty good one. It covers almost all the bases, okay? And the reason is we could do ASCII, by the way. Anybody heard of ASCII? A little older one, ASCII. What happens there? Well, that does work. Look at that. Same thing. But with ASCII, ASCII is a very limited encoding. It uses, ASCII is 8 bits. That's it. So how many different numbers can I have with 8 bits? Well, 255, technically 2 to 6 becomes 0, right? But for non-zero, that's it. 255 characters. Now, if you count 52 in the alphabet, upper lower case, plus some symbols, you're getting close to quite a few, right? So this is very English-centric. Okay, it's very English-centric. So now they have what's called UTF-8, which holds a much larger number. In fact, it holds, I think it's 1,112,064 combinations. That's how many characters UTF-8 can hold. That's a lot. Pretty much every language plus some emojis thrown in and some other stuff. That's a lot. So UTF-8 is it's a very common encoding to use. And it's one we almost always see used almost everywhere. Handles all the languages, right to left, left to right, every Asian language, pretty much everything can be represented in UTF-8. Okay. Let's change our code now. It's going to show the length just for fun. There. Let's take a look, run our code. There we go. Clear. So 232 characters in our file. So our file was loaded and we read 235. Let's try this now as an async instead of a sync. So the other function, and the more common one used, is read file. Well, now we can't use the return anymore. Instead, we have to give it a callback at the end. So file name, options, we'll make this UTF-8 again, UTF-8, and a callback like that there. And the callback returns the information to you, gives you two things, an error and data. Now this is a return. This is what it's sending to you. You're getting these things back from read file. Let's take a look. Console log, data dot length. Let's see what happens. Same thing. It's console log data. And it worked. Let's do our usual console log start of code and end of code. And now watch what happens. Once again, callbacks never fire until JavaScript's not busy. So it happened at the end. This callback was guaranteed to happen at the end of our code. Let's console log both. Console the error as well. ERR. Let's console log both of them. Null and our data. So if there's an error, this read file will give us an error here. let's just make some random error. Let's go, we'll call it data3, a file that doesn't exist. Try that. Okay, so I get some interesting message. Really great. There's my error. And of course, my data is undefined. I couldn't read the file, so my data is undefined. What I probably should do here is check if I have an error. So I can go if err. I'm going to console log the error. There. Now I could do an else. But now we know better. Don't use else, right? So I'm not going to do an else. I'm going to instead put a return. It's game over. Once there's an error, there is no point in continuing. There. And by the way, this also works. Return. Since read file doesn't care what you return. You can do this. This is more common. It just makes it one line. So if there's an error, console log the error. If there's no error, print the data. So now let's watch what happens if our code runs now with the error. We get the error. Let's take the error out. Runs without the error. So this is commonly used for asynchronous, and this is a classic example of asynchronous code. What if we wanted to run or read another file after reading the first file? And I'm just making them a class or a simple example. Read two files and get the length of both files combined. Fair enough. Why, it was two read files, right? There. Let's make a data2 there. Make a file. Come on. They're going to copy. Try it again. There we go. I'll call this data2. And I'll just take out some stuff. I'll make it a little shorter. There we go. Total nonsensical Latin. So I want to add the lengths of these two files together. Okay. So that's my assignment. How's that going to work? I like to do two read files like this. Let's see if I can get my data. Let's go ahead and run this. It worked. There's my data1. Wait a second. Now, isn't that odd? That's my data2. It's smaller. Why did that one fire first? Huh. But I clearly said read my first one, my data first, and then read data2. But it looks like it printed my data2 first and then my data. Can anyone explain why that would be the case? Why did data2 print first? Let's recap what we know about asynchronous. Line 1. This is tracing code, and make sure that you're very aware of your line numbers. Make them bold. When you get a mentor's help, they will say, go to line 12, go to line 15, and you'll be looking for your line numbers. We live and die by line numbers. So line 1, choir, great. Line 3, console log, so far. Then it calls line 4, fs read file. That's asynchronous. So that returns instantly. Nothing happens, right? Nothing happens. It simply sends a message to Node saying, hey, read this file, please. Now we're here in like a nanosecond. Second read file. Now we're here in a nanosecond. We cause like an end of code. Okay, now we're not busy. Of course, Node has already been chewing away at those two files. Which file do you think it finished first? The large one or the small one? The small one. So it finishes this one first, and this callback fires. and I get my console log data of my small file first. So it's not the order they were called. It's whoever gets to send the message first. Whoever gets done, I'm done. And they notify Node and JavaScript gets the event. Okay, so I've got my two, but how do I get the lengths? Let's console log data dot length there. And this one here. Okay. And let's take a look and see what we get. Well, there they are. So I just have to add those now. How hard can that be? I have two numbers. I just have to add these two numbers. But how do I do that? Like, how's this going to work? Because it's inside here. And these are two different callbacks. How on earth am I going to get? Would I maybe make a variable? Maybe I can go let length 1 equals, we'll just put it here, and then say length 1 equals data.length. Maybe this will work. Let's try this. There. Or let's call it length, even better. And then here I can say length plus equals data.length. In fact, to be safe, I'm going to make them both plus equal because I'm not sure which one's going to get there first, right? There. I've covered all my bases. That and that. Okay. Let's take a look. And let's console log length right about here. Log length. Okay. How hard can this be? I'll say length equals or total equals. There. Okay, here we go. That should be 343. Come on, 343. Undefined. What? What happened there? Well, okay, I'll make it equal 0 because I know I can't add undefined plus a number, so I'll try this instead. Okay. Okay, come on, 343. 0. That's disappointing. Huh. This didn't work. Why didn't it work? Once again, we trace the code, right? Length equals 0. Blows past that. Blows past that. 0. Of course it did, because those didn't do anything. And then later on, we do this. And I'm sure it set the length, but we're done, right? So maybe we can somehow combine this, but how can I do that? So what I think I need to do is this. I think I can do this. I'm going to put my second read file inside my first read file. Huh. And now, there we've got that. And my total right there. Let's take a look. How am I doing here? And this one goes here. There, that's my first file. There's my first file. There. Now I call read file again once the first file is read. But now I have access to this same length. Let's take a look. 343. Look at that. And it happened after they both got read. So this is common. We will talk more about this later. I think the next lecture we talk about nested callbacks and how nasty they can get. For now, we'll leave it at this. And then a little later, we talk about promises, which are super awesome. All right. That is our talk today. Didn't quite have time to talk about closures. We may talk about closures in the next lecture. they're not async related, but they're kind of cool. So we talked about synchronous, asynchronous, and we talked about some asynchronous functions. And the important takeaway is a asynchronous function executes and returns immediately, no delay. And then later it calls this callback. That's because JavaScript is single-threaded, non-preemptive, and we use callbacks and asynchronous to have things happen after the main thread is done. That is our talk for today. I do apologize for my scary voice today. I think by next Tuesday it should be all better. All right, everyone, have a great rest of your Tuesday evening. I will talk to you again next Tuesday.